Okay, so let's look at this question now, part C. The plate in B is covered when stationary with mud. Suggest and explain whether mud near the edge of the plate or near the center will first leave the plate as the angular speed of the plate is slowly increased. Okay, so we have to decide on this and then you have to explain. Okay, so what happened here is you still have the plate in this way and it's rotating. This is the center of the circle. Now you have two situations. You have mud near to the edge and you have mud near to the center. Okay, so let's say this is mud A, and let's say this is mud B. Okay, so we want to know when the plate is rotating and increase in speed. So which mud will slide off first? So which mud will slide off first? Huh? Okay, so let's see how are we going to understand it. Huh? How are we going to understand it? So we have mud A, mud B. Both have the same frictional force. So you need to know the plate is made from the surface of the plate is of the same roughness. So hence they have the same frictional force. Okay? Same frictional force. So first thing, mud A and mud B have the same frictional force. So frictional force is the only force that acts towards the center of the circle. Okay, so imagine that the motion is outwards, where the mud is may slide off. Okay, may slide off when the plates rotate faster and faster, then the mud may slide off. So the motion is outwards, and the frictional force is hence inwards. The frictional force. So this is frictional force. Same value lah actually, because like what I said, they have the same roughness. Okay, they place at the same plate. So they have the same frictional force. That is the thing. Okay, but the other thing is centripetal force frictional force provides centripetal force. I write down first. Frictional force is equal to centripetal force. So frictional force is equal to mr omega square. Mr omega square. So now let's compare between mud A and mud B. When we have Ff equal to mr omega square, the frictional force is just 0.72 W equal to mr omega square. Okay. Now, the difference between mud A and mud B is mud A has small r. Mud A. So, mud A, RA is small. Mud B, RB is bigger. It's bigger. Okay, so that's the difference. So they have difference in radius. Okay. Now, because mud B has a greater R, Okay, I write down first. Mud B has a greater R. has a greater R, that means it has a greater centripetal force. A greater, okay, I write short form lah. A greater centripetal force than mud A. Obviously, this is true, right? So mud A has a smaller centripetal force. Mud B has a greater centripetal force. Okay, so because they have different radius, it means that you need to know centripetal force in this way also. Centripetal force is also the force that hold the object in circular motion. Okay, so that is another meaning of centripetal force. Okay, centripetal force is the force required to hold the object in circular motion. So that means mud B has a greater centripetal force. Mud A has a smaller centripetal force. That means what? That means you want to hold mud B in circular motion, you require a greater force to hold it. You require a greater force to hold it compared to mud A. A greater force to hold it. So our frictional force is not enough to provide that centripetal force when the plate is rotating faster and faster. Okay, I write down first. The frictional force is, okay, maybe I put like this first. Okay, when omega increase, when omega increase, that means the angular velocity increase. The question said the plate is moving faster and faster. So when omega increase, the frictional force is not enough to provide the FC, to provide the centripetal force for mud B to remain on the plate, and hence it slides off first. So basically it's like that. Mud B needs a greater centripetal force. So when the thing rotates faster and faster, the frictional force, which is the same value all the time, is not enough to maintain mud B on the plate, as mud B require a greater centripetal force. So not enough to provide that value, then it's like off. So the idea is like that. But the question is just a 2 marks question. How to summarize all this information in 2 marks. So first, you see, the first point you can say it in this way. Centripetal force increases as R increases. So this point is important, so we must mention this, and you get 1 point for this explanation. explanation. So there's just one short explanation. You know, they give 2 marks, right? One is explain, another one is you suggest which mark will fly off first. So okay, now so mark near the edge. Mark near the edge of the plate will first leave the plate. Okay, so just like that. Short explanation is enough already for exam. So mark near the edge will slide off, will leave first because centripetal force at the edge is larger. And many people will be wondering, maybe they are wondering about why centripetal force is larger than what happened. No explanation here. They expect you to know on your own. Something like this will happen. Okay, so settle for this one. Now let's just move on the other side. So we have another question here. Okay, we do one more question. Then after that, we just move on to the next chapter. Okay, so these questions define the radian. Okay, so it's the same definition. Angle, subtended at the center of circle by an arc equal in length to the radius of the circle. Okay, now let's look at B. A stone of weight 3.0 Newton is fixed using glue to 1 np of a rigid rod CP as shown in figure 1.1. So you can see here the stone and the rod. The radius is 85 cm. Okay, let's look at the next page for the questions.